Hi guys, welcome back to my channel, and today I'm going to be telling you about segment trees. Segment trees are a way to do range queries. In this case, I'll be showing you how to do some range query, but you can also do minimum, maximum, and many others. Here I have the segment tree that we're writing about in this program. Initially, all of these positions start at a 0, but you would add a number to them. Now the reason we do it like this is the way that the segment tree is made. Here, the original array, which was doing the range queries on, is 3, 0, 1, 2. And for every 2, we have the sum of those ranges, and then we combine those two for those ranges. Obviously, the longer the original array is, the more levels of the tree would have. Now, the way that it's maintained like this means that you should normally use a array of power 2, and if you don't have an array size that's a power of 2, you can just have some hanging zeros at the end. Now, the way that we actually store this is that you have an array, and at the beginning it's the very top, which is 6. Now after that it's both of its children, which is 3 and 3. Now 3's children are in the next 2. So the first 3's children is 3 and 0, and this 3's children would be over here, which is 1 and 2, and that's it. So in this way, that is why we have an add function. Now what the add function basically does is, in this case, we're changing this one over here into a 10. So what we do is we make this one a 10, and then essentially we bubble it up. So we go to the parent of the 3 and 10 range, and we update that to 13, and then we go to the 6 range, and this becomes 16. And if we want to do a sum, then what we can do is we can take the biggest section of that range, we take the node that represents the sum of that, and then after that we keep on bubbling down to the more and specific values. So in this case, we're doing the sum of 1 to 3, which is this. So it would add 3, which is this one, and this guy over here to create the final. Over here, you can see some sample code I've written. You have the STN, which is the size of the segment tree, which is, of course, a power 2. In this case, it's 2 to the power of 2. You see it's 1 less than 2, because that's how bitwise operators are used. And that's how they look like. That's the same as raising 2 to the power of 2, which is 4. And because of how this segment tree is implemented over here, we multiply that by 2. Then we have the sum function, which does what I talked about earlier, taking the greatest range that we have the node for and trickling down until we account for all of the ranges. And an add, where we trickle the change up. Now in this right here, I'm adding all the initial values, doing the sum of indices from 1 to 3. At first, this will be 3, right? Because 1 is 0, and over here it's 3. And after it, it should be 13, because this changes to 10. So let's see what the program does. Just compile it, and then here we go. As you can see, it works perfectly. And you can also change this for min-max, except it would work a bit differently with the addition and the sum method. Basically, instead of doing the sum, you would trickle down, or you would trickle up the min or max for the addition function, which in that case it wouldn't be addition, right? It would just be an update function, and the sum would just be going down and keep on comparing all of the values. So in this case, the sum and add are both log n. So you get queries and updates are log n, and this is very useful for problems where you have to repeatedly do range queries, and if you keep on changing them and having to update them. So thanks for watching. I'll see you next week. Like and subscribe if you enjoyed the video, and have a good day.